Okay, so I wanted to do a couple of the problems from the review today so you had something to kind of study for tonight. The first one we're going to look through is that first section. So we are given the sine of 15 degrees. So there are two methods to do this problem. The first method is to use a half angle identity. So to say that this is really the sine of 30 over 2, where 30 is now our x value in that problem. So for example, we would use this identity that we have, where sine of x over 2, and we would plug it into this formula, negative 30. Oops. The other method to use is a sum and difference. So we would say that the sine of negative 15 and change that to someone where you could like add two things together or subtract two things. So we could say that that's really sine of 30 minus 45. So that is negative 15, so we can make the same thing there. And then we would use this formula, the sum and difference, and plug it in for a and b. So I'm going to go over both these methods. So the first one, using our half angle identity, sine of x over 2. So negative 30 over 2 equals plus or minus the square root of 1 minus cosine x, and our x value is negative 30 in this case, over 2. And we have to decide what quadrant we're in to decide what positive or negative value we're using. Well, it's negative 30, which means we can find a coterminal angle by adding 30 degrees to that, which would mean, it's negative 15, which means we can find that coterminal angle. We're going to end up here in quadrant 4. And to evaluate cosine, this would be a 30-degree angle for my reference triangle, meaning that this is 1/2 negative, and this is root 3 over 2. So again, this is a negative value for my sine, being in quadrant 4. 1 minus cosine of 30 is root 3 over 2, all over 2. And when we evaluate that, we simplify the top, so we find a common denominator. This is 2 over 2, so 2 over 2 minus root 3 over 2 means we have something that looks like this, and that's all divided by 2. And remember, this is like a fraction and a fraction, so we would multiply by flipping the denominator, multiply by 1/2. And then we would take the square root of the top and the square root of the denominator. The top we can't simplify anymore, then we take the square root of the denominator and we get 2. So this is one possibility of our answers for sine of negative 30 over 2. And you only have to pick one of these methods, whatever works best for you. The other possibility is to use a sum and difference. So that's splitting our angle into two angles and using this formula here. So this is now a and b. And we're using the difference where my a and b are both positive, a minus b, or minus our b value. So this is the sine of a, so sine of 30, times the cosine of b, which is 45, minus the cosine of a, which is 30, times the sine of b, which is 45. Oops, sorry. And the sine of 30 degrees in our reference triangle, the sine of 30 degrees is 1/2. Cosine of 45 is root 2 over root 2. Cosine of 30 degrees in my same triangle is root 3 over 2. And the sine of 45 is root 2 over 2. And if we multiply out the tops, we have root 2 over 4. 1 times root 2 is root 2. 2 times 2 is 4. Minus root 3 times root 2. Multiply the insides. 3 times 2 is 6. Multiply the denominators is 4. So we get root 2 minus root 6 all over 4. Now these don't actually look like the same value, but they are equivalent. If we were to simplify this somehow, we would get that these two things are the same values. Okay, so we're going to do number 3 on this same number 1. And this is the cosine of 67.5. Okay, so here's my problem with this one. The cosine of 67.5. We cannot split this up into some sum and difference where we have like 37, 0.5 plus whatever, because that 0.5 here throws us for a loop. There aren't any 0.5s on our unit circle, so we have to use some sort of double angle for this. So I'm going to use the cosine of x over 2 in this case, and my x value, to find that, we need to multiply that by 2. So 67.5 times 2, if we do that into our calculator, we get 135. And that is a value that's on our unit circle. And we're going to plug it into this half angle formula for cosine. So plus or minus square root of 1 plus cosine of x. And our cosine of x, in this case, or our x value is 135 over 2. Now to decide what our deal is for plus or minus, we have to look at this value. And this value, our theta, is in quadrant 1. So we're going to take the positive version of this fraction. So positive 1 plus cosine of 135, that's in quadrant 2. It's a reference angle of 45 degrees. In quadrant 2, my cosine is negative. So this is negative root 2 over 2 over 2. Again, find a common denominator. This is 2 over 2, 2 plus root 2, negative root 2 over 2, all over 2. Meaning I have 2 plus negative, which is 2 minus root 2 over 4. Again, multiply by the reciprocal if that helps you. 2 times 2 is 4. And then take the square root of the top, 2 minus root 2, and the square root of the bottom, which is 2. Again, you can check this in your calculator. So if I put in the square root of 2 minus the square root of 2 and divide it by 2, I get 3.38268. And if I find the cosine of 67.5, I should get the same value, 0.38268. Okay, so you can check this as you go. Okay. I also want to look at the second thing that we have on that sheet, and that was saying that you're given the tangent of x is negative 2 and x is in quadrant 2. And you're trying to find the sine, so part A or part 1 was the sine of 2x, and we're trying to find the cosine of 2x and the tangent of 2x and the quadrant. So we'll start with sine and cosine. So using sine and cosine of the double angles, we are using this formula. So sine of 2x really means that we need sine of x and cosine of x. And right now, all we're given is the tangent of x. So we don't have sine of x and cosine of x, but we can find that using a reference triangle. That's why it tells us that x is in quadrant 2. So we draw our reference triangle, quadrant 2. Remember, this is really negative 2 over 1. We have to be careful though. This is negative 2 over 1, so our opposite isn't negative 2 in quadrant 2, it's just 2, but our adjacent's really negative 1. So that's how we're getting that negative 2 of 2 over negative 1 rather than negative 2 over 1. And then we can find this value, so 2 squared plus 1 squared, 2 squared is 4, plus 1 squared is 5, gives us our hypotenuse of root 5. So our sine of x is 2 over root 5, which is 2 root 5 over 5. And our cosine of x is negative 1 over root 5, which is really root 5 over 5. So we have cosine of x and we have sine of x. And we're going to plug those values in to find sine of 2x. So the 2 stays. And we're going to replace sine of x and cosine of x. Sine is 2 root 5 over 5. And the cosine of x is negative root 5 over 5. Okay, this is really negative 1, so we multiply all the numbers on the top. 2 times 1 times 2 times 2 times 1. Negative 1 is negative 4. Root 5 times root 5 is 5. Roots cancel out, and then the bottom 1 times 5 is 25. So this is negative 20 over 25, which is really, if we reduce that, negative 4 over 5. So the sine of 2x is negative 4 over 5. Okay, we're going to do a similar thing for the cosine of 2x. So the cosine of 2x, we just pick one of the values that we have here. So I'm going to pick this first one, 2 cosine squared theta minus 1. And we have cosine of x right here. So let's plug it in, negative root 5 over 5. And we're squaring it. So I'm going to square that first. Square the top, so root 5 squared, negative squared is going to be a positive. So root 5 squared is 5. On the bottom, 5 squared is 25. This is 10. 2 times 5 is 10 over 25 minus 1. This is really 25 over 25. So 10 minus 25 is negative 15 over 25, which reduces to negative 3 over 5. Okay, so for part C, finding the tangent of 2x, you can use this formula that we have. Tangent of 2x is 2 times the tangent of theta, 1 minus tangent squared of theta, and then you'd have to find theta above. But we have sine x and sine of 2x and cosine of 2x, so I'm just going to find the ratio of these two things. So the sine of 2x is negative 4 over 5, the cosine of 2x is negative 3 over 5. Those cancel. Negative 4 over negative 3, which is 4/3. And then part D says, what's the quadrant of 2x? Well, the quadrant of 2x, we have to look at all the values we just found. We just found sine of 2x and cosine of 2x. The sine was negative and the cosine was negative, which means that we are dealing with quadrant 3. Okay, we're going to do number 6, or station 6, whatever you want to call it. And it gives you the cosine of A is negative 2/3, and the sine of B is 5 over 13. And it says that A is in quadrant 2, B is in quadrant 2, and you're trying to find sine of A plus B, cosine of A plus B, tangent of A plus B, and the quadrant of A plus B. So this is kind of similar where we're starting with these simple ones and we're going into something a little bit more complicated. So the sine of A plus B means that we need the sine of A, cosine of B, plus the cosine of A, sine of B. And the cosine of A plus B means we need the cosine of A, cosine of B, minus the sine of A, sine of B. So what we have right now is the cosine of A and we have the sine of B. So we can replace that already, but really what we need is the other two. So I'm going to draw 2 reference triangles. This one's going to be the reference triangle for A. This is going to be the reference triangle for B. And we know that they're both in quadrant 2. So A gives us the cosine of negative 2/3. And we can find this value so we can find the sine. So we would complete our Pythagorean theorem. This is y, or 9, 3 squared minus negative 2 squared. 9 minus 4 is 5. So this is root 5. Okay, which means that sine of A, this is our A value inside, that's our angle, is square root 5 over 3. And then B, we're doing the same thing, except we have 5 and 13, which that's one of our triangles that we know already. So this should be negative 12, which means our cosine of B should be negative 12 or 13. Okay, so now we have all our important pieces of information for us to evaluate our sum and difference. So our sine of A is root 5 over 3. Our cosine of B is negative 12 over 13. Our cosine of A is negative 2 over 3. Our sine of B is 5 over 13. This stuff we can just multiply the numbers out front, which is just 1 in this case. We just combine them as negative 12 over root 5 plus negative 10. And these are going to have a common denominator, so I'm just going to put them in a common denominator already. And 3 times 13 is 39. So this is the sign of a plus b. And we cannot simplify that any further. We can't combine this negative 12 and this negative 10 to make negative 22 because we don't have like a root 5 here. So we leave this as it is, just like that. Okay, so we're also asked to find the cosine of a plus b. So again, we're just going to plug in the stuff that we know. We know the cosine of a. We know the sine of b. So we can just plug that stuff in. So the cosine of a is negative 2/3. The cosine of b is negative 12 over 13. The sine of a is root 5 over 3, and the sine of b is 5 over 13. Again, we're going to have a common denominator of 39 as we were going into this. For this one, we have negative 2 times negative 12, which is 24, minus 5 root 5 over 39. Alright, so then for the tangent of a plus b, again, don't make this hard on yourself. You don't have to plug it into the big long tangent sum and difference formula. We have our sine of a plus b, and we have our cosine of a plus b. So we'll just take our ratio of those, negative 12 over root 5, or times root 5 over 10 over 39, 24 minus 5 root 5 over 39. And we'll notice that we have the same denominators here, so those cancel. So we're left with negative 12 root 5 minus 10 over 24 minus 5 root 5. And that's our tangent. Okay, so then for the quadrant of a plus b, we have to again look at our sine value and our cosine value. So what I would do is I would look at the numerator of this, because our denominator is positive, which means if we have something that's negative over something that's positive, that whole quantity is going to be negative. And this one you can tell right away that it is negative. We don't even need to compute it, but we get negative 36.83. So our sine value, just going to make a note, our sine value is negative. We're going to find our cosine, so this would be 24 minus 5 root 5, and then we would divide it by 39, so this is going to be positive. And that tells us right now, sine's negative, cosine positive, this is quadrant 4. Okay. Good, we're going to do, I'm also going to do number 7, or it's the station for 7. So it says cosine of 2x equals 3 over 4, and x is in quadrant 3. And we're trying to find sine of x, we're trying to find cosine of x, and we're trying to find tangent of x and the quadrant of 2x. Okay, well what we need then, again, is that we need our double angle identities. So our double angle identities over here for cosine of 2x is 2 cosine theta. I'll write that here. 2 cosine squared theta minus 1. And this equals cosine of 2x, 2 theta. And then sine of 2 theta, or sine of x, excuse me, we need something that deals with our sine of theta, which is here. So the cosine of 2 theta also equals 1 minus 2 sine squared of theta. Okay, so as we're doing this, we should be keeping in mind what we're given and what we're trying to find. So again, like this time we're given 2 theta, so we're trying to use our double angle identities to solve for the other things that are in our problem. So, for example, for this problem at least, we are plugging in 2 theta. So we're going to plug in 3 over 4. And we're going to try to solve for sine. Okay. Well, when we're solving this, we're just like solving this like any normal equation. So the first thing we're going to do is subtract 1 on both sides. So we get negative 1/4 equals negative 2 sine of theta squared. Then we would divide by negative 2. So we'd get positive 1/8 equals sine of theta squared. And then we would take the square root of that. And we get 1 over square root of 8 is 2 root 2. And when we rationalize this, we just multiply by the radical of root 2. So the top we have root 2, and then 2 times root 2 times root 2 is 2, so 2 over 4. Okay, and it also tells us that x is in quadrant 3. Oops. So this tells us the sign of this, which means that since our x is in quadrant 3, this is going to be a negative value. So you always have to go back to what the problem gives you, and for this case, we're dealing with we're dealing with quadrant 3, which means that those things are negative. So the cosines also be negative when we plug that in. So 3 over 4, 2 cosine squared theta minus 1. So first thing we're going to do is plus 1, add 1 to both sides, and we get 4 over 4, which is 7 over 4. And then divide by 2, and we get 7 over 8. And again, take the square root of 7 over 2 root 2. And again, this is negative since it's in quadrant 2. We rationalize by multiplying by root 2 over root 2, and we get root 14 over root 2 times root 2 is again 2 times 2 is 4. Okay, our tangent of x, we can find that now that we know these things, and we can use like actually draw these as a reference, but we don't really need to do that right now. Since we know sine of theta and cosine of theta, I should be using x, I guess. So this is negative 2 root 4 over negative 14 over 4. 4's cancel out. Negative over negative turns into a positive, and this root we can actually simplify into 2 over 14, which is really root of 1/7. And when we rationalize this, if you didn't see that, that's okay. You could have gone about the other way, but you'd have more work for yourself. We should get our answer of root 7 over 7. Okay, so then for the quadrant of 2x, well, I know that cosine is positive for this because it tells us cosine of 2x is 3 over 4. So I'm going to write down here that the cosine is positive. And real quick, I'm going to find the sine of 2 theta, or at least think about it. So the sine of 2 theta in our trig identities is sine times cosine times 2. So the sine value is negative. The cosine value is negative. If I multiply those two things, I'm going to get positive, and I multiply by positive 2. So our sine of 2 theta is going to be positive as well, which means we're going to be in quadrant 1. So you don't have to compute it. You can just think about and rationally think about how we could get that after we found our sine and our cosine. Okay, the last one I'm going to talk about is 8. And it gives you sine of theta is negative 3 over 4. Theta is in quadrant 3. And we're finding the quadrant of theta over 2, x over 2. We're finding sine of x over 2, cosine of x over 2, and tangent of x over 2. So let's find the quadrant first. So if theta is in quadrant 3, that means that it's between 180 and 270. Divide everything by 2. We get between 90 and 135, which is in quadrant 2. Okay. And then for our second part, we're trying to find sine of x over 2. Okay. So again, we're using our half angle identities here. So we're going to plug it into this formula, plus or minus square root of 1 minus cosine x over 2. The problem is we don't have x over 2. Really, this should be theta. We don't have cosine of theta. We have sine of theta, but we can find cosine of theta by graphing it. In quadrant 3, negative 3 over 4 is our opposite over our hypotenuse, and then we can find our x value. So 4 squared is 16, minus 9 is 7. So this is root 7, and it's going to be negative in quadrant 3. So our cosine value is negative root 7 over 4. And that's where we're going to plug into our formula. And again, theta over 2 is in quadrant 2, and our cosine's negative there. So this is 1 plus, and we'd simplify the top. So I'd have 4 over 4, so 4 plus root 7 over 4, all over 2, excuse me. Multiply by the reciprocal, or combine our denominators, we'd get 4 plus root 7 over 8. And then I'd rationalize this by multiply by root 8 over root 8. And when I do that, I just multiply the inside. So I'm going to write it this way. 8 times 4 plus root 7 over 8. Oops. Sorry. Over 8. We rationalize that, so that root should just be on the top. So if I distribute that through, I should get 32 plus 8 root 7 for sine of theta over 2. Okay. So then for the next one, finding cosine of theta over 2, we do the same process. The sign of, this isn't, shoot. This is positive, sine's positive in quadrant 2. Cosine's negative. So for the next one, our cosine of theta over 2, we're going to have the negative version. So when we do this, it'll be 1 plus cosine x over 2, negative. We have the same cosine value. It's negative root 7 over 2 over 2. We end up with the same stuff that we had before, except we have a negative version there. Again, doing the same situation that we just did up here. Multiply by root 8. And again, I'm going to write it this way, where I have, oops, can't see that. I'm going to write it this way, where I just multiply my insides, and I get 32 minus 8 root 7 all over 8, and a negative out front. And then the tangent, I'm not going to do, but you would just do this over this, and then you don't have to simplify that. That's all right. The 8s will cancel out. You'll get negative, or root 32 plus 8 root 7 over negative 32 8 root 7. Okay. Hope this was helpful.